Hello, and today's purpose of the day is I can solve application problems involving trig ratios. For a warm-up, please solve the triangle. We need to solve for all of the missing measures of the triangle, including sides and angles. So everything that we need to solve for are sides and angles. So let's first look at the sides. I am missing this side over here, which is directly across from angle B. Therefore, I need to solve for side B. And again, we denote the sides across from their angles. So if this is angle B, we call this side lowercase b. And then this side here would be C because it's across from the angle C, which is 90 degrees. And then we are also missing angle A, so we'll call that theta, and a little symbol. Looks like an O with a little curly Q on that, so we'll call that theta that we need to solve for. So let's first solve for the missing sides. Let's solve for side B over here. So I know this angle here of 17 degrees, and so to solve for side B, I am going to say I know the opposite over the adjacent, which is tangent of 17 degrees equals b over 13. So I would multiply by 13 to both sides. And 13 times tan 17 is 3.97, so rounded to the nearest tenth would be 4.0. So b equals 4.0. And now I will solve for side C. So I know adjacent with this 13 and hypotenuse. So adjacent and hypotenuse go with cosine of 17 degrees equals adjacent over hypotenuse. And here now when we have the variable in the denominator, we can go ahead and do that little flip and get C equals 13 divided by cos 17. Rounded to the nearest tenth, we get 13.6. And then lastly, we can solve for the missing angle. And we could do this a couple different ways. We could solve by using a trig ratio and set that up. Or we could just say, hey, 90 plus 17 equals 107. What's 180 minus 107? That would be 73 degrees. So we know that that angle right there would be 73 degrees. And now we have solved for all the missing parts of this triangle, including sides and angle A. Find missing measures in the similar triangles. Find the missing measures for the pair of similar triangles if triangle PQR is similar to triangle STU. Well, we know some of the sides over on the right-hand side, so let's go ahead and label all the sides that we know. Q is equal to 6, S equals 2, T equals 3/2, and U equals 1/2. Now we can go ahead and set up ratios and proportions that will match up the sides of the two triangles. So let's look at solving for R first. So I would set this up as saying 6 over 3/2, so I'm going to compare those sides first, equals R, the unknown, over this side right here, which is 1/2. And if I need to look at that a little bit differently, I could also write that as 6 over 1.5 is equal to R over 0.5. And now I just need to cross multiply and divide, and I get that R is equal to 2. Now for the other missing side, I need to solve for P. So I can say again 6 over 3/2 or 1.5 is equal to P over 2. And cross multiply and divide. And I get P is equal to 8. So I've just solved for the two missing sides when given similar triangles and given their other sides. Now let's take a look at 10.8 Day 3 Trig Application Word Problems. Surveying. If point A is 54 feet from the tree and the angle between the ground at point A and the top of the tree is 25 degrees, find the height h of the tree. Well, this is really nice because we're given a picture for this word problem. Not all the time will we be given pictures for the word problems, and that's really the difficult part, is trying to set up what the problem will look like as a picture, because then it's quite easy to see what we need to solve for. So with this example, we know we need to solve for the height of the tree right there. We're given our angle of 25 degrees, so I'm given the opposite side and the adjacent side. So this would be tangent of 25 degrees is equal to h over 54. Then we would multiply by 54 on both sides. and get h equals 25.2 feet when I round to the nearest tenth. Another problem, Washington Monument. Jeannie is trying to determine the height of the Washington Monument. If point A is 765 feet from the monument and the angle between the ground and the top of the monument at point A is 36 degrees, find the height h of the monument to the nearest foot. Well, again, this is really nice because we're given a picture and we clearly know what we need to solve for h. So if I'm given 36 degrees as my angle, I know I'm given the opposite side and adjacent, so it appears that this is another tangent problem. So I could say tangent of 36 degrees is equal to h over 765. Again, opposite over adjacent. So multiply by 765, and 765 times tangent of 36, rounded to the nearest tenth, would be 555.8 feet. And again, it's always good to check and see if your answer makes sense with the information that you're given. And here, 555.8 feet would make sense for the height of this monument for this problem. Truck ramps. A moving company uses an 11-foot-long ramp to unload furniture from a truck. If the bed of the truck is 3 feet above the ground, what is the angle of incline of the ramp to the nearest degree? So, we need to draw a picture for this problem because we do not have a picture already given, so please take a moment on your paper and try to draw a picture that would represent this word problem. Great job! Your picture looks very similar to mine. So here we have the 11-foot ramp and it's 3 feet above the ground, so you can imagine that the truck would be, still going that way. So we need to figure out the angle of incline, which means obviously looking upward or going upward. So we need to figure out this missing angle, again we'll call theta with that symbol. So if we know the opposite over the hypotenuse, that's going to be with sine. So we are going to say sine of, we could call this A, sine of angle A equals opposite over hypotenuse, 3 over 11. So now this would be an inverse sine problem of 3/11 equals angle A. So rounded to the nearest angle here, so inverse sine, we can type in our calculator, of 3 over 11 would give us 15.8 degrees. So angle A here, the measure of angle A would be equal to 16 degrees. A pilot takes off from a runway at an angle of 20 degrees and maintains that angle until it is at its cruising altitude at 2,500 feet. What horizontal distance has the plane traveled when it reaches its cruising altitude? So it appears we do not have a picture to go with this problem, so please take another moment and draw yourself a picture that would match with this word problem. Nice work setting up your picture. So here's what our picture looks like. So we know this angle here, and we know the opposite side, and then we need to solve for the adjacent side. So this would be tangent of 20 degrees is equal to opposite over adjacent. And here again is when we have our variable in the denominator. We can do our little flip and get h equals 2,500 over tan 20. And if we round our answer to the nearest tenth, we get 6,868.7 feet traveled. A couple last notes to talk about are angles of elevation and depression. So you'll see a couple of these words used in the word problem practice. And so angle of elevation means that you are looking up from the ground level toward the top of an object, which would look like this. So this would be the angle that would be the angle of elevation. Then depression, looking down from an object to the base of another object. So the angle depression could be somewhere in the top looking down. So a picture just like that. So please write these notes down so that you have them to reference later. Thank you for listening. Please see Schoology for more information. Have a great day. Bye-bye.